In the previous video, I desoldered the wire that connect the horizontal plate here, and we got a vertical trace. So now we know that the high voltage part is okay, and the vertical amplifier here. I found this schematic from BK Precision scope, model 1405. It's almost the same schematic with this scope. There are a tiny difference in the voltage maybe. So now I will see if we got a sweep signal here in the horizontal amplifier. Here is the part. Here we have the oscillator, and here we have the horizontal amplifier. I printed the part of the schematic. I will test here in this MOSFET if we have the horizontal sawtooth signal. So I will solder here for the ground. I will solder a wire. And I will use this tiny scope to see if we have our oscillator is okay, because the horizontal part it's the source of the problem. I will connect the ground of the scope here to have more freedom. I will now power the scope. I will use 1 volt for division. Here we are in the DC setting. I will power the scope and I will see if we have the horizontal oscillator works. So here we have the MOSFET. Here we have the gate of the MOSFET. I will power the scope now. We can see that we have our sweep sawtooth signal. We can vary the frequency. It's not clean. We can adjust. Syncing. Now we have clean signal. We can adjust the amplitude and the frequency here. Here the position. I will try to use 0.5 volt. So I will see in the source of the MOSFET here. Here in the source we have the signal. I will use 1 volt. So maybe the problem with the high power amplifier, the output amplifier. Here we have the schematic. we have here the oscillator. Here we can found the knob for selecting the frequency of the horizontal sweep signal, and here we have tau transistor for the output amplifier. Here we have plus 160 volt here between those two resistors, and here we have the tau plate, Y plate here. If we see the trace here, we have here those are going to the horizontal plate number 12 and 13 of the cathode ray tip. I will see if the voltage are okay, and I will test here this potentiometer horizontal position and horizontal gain. I will disconnect. I will first try to see the voltages. You can use the case of the ground. I will power the scope. Here I have plus 9 and minus 9 volt. Here we have plus 9.5, and here we have minus 9.7. Here we have plus 150 volt. They said 150 volt. You can see here we have 170. We have 20 volt over the normal voltage. Maybe due to our line voltage. We have here 200, maybe 240 or 50 volt in the line, in the output line. We can use here as a voltage. I will verify the line. I have a protection in the outlet. Maybe I will use our power meter. So we have 240 volt here in the main voltage. We have 240, and this scope is rated for 220 maybe. We have now selector for the voltage here, maybe 220. So I will test again. Here we have 170, and here for 170 we have 190. We have 20 volt difference. So I will try to verify this part here. We have tau NPN transistors and some resistor here. So we must found this trimmer here for DC balance. Here we have the vertical position. It's connected via this resistor R124 to this tiny trimmer. Now we can see here we have the same PCB, of course. Here we have this tiny trimmer with the 3 pin used, and the others they use only 2 pin. They use them as a variable resistor. So I will measure here between this one and this tiny potentiometer and the vertical position potentiometer. We have 2.5 kilo. Here we have this resistor between the two variable resistor. So I will power the scope and I will adjust this trimmer here in order to get the trace in the center of the CRT. I have a photo, so I didn't lose the initial position, or we can, of course, here take some measurement in order to return to the same position if we haven't succeeded to get the correct position. So I will here measure the resistance in order to don't lose the initial adjustment. I can measure here. We have here 0.7 kilo ohm, 0.75, and here 235. Now we have 754 ohm. Here we have 754 ohm, and here we have 232. So if we lose the adjustment, we can get the proper value, the first proper value. I will now power the scope. Here we have, we put now this position to we put the vertical position at the middle. Now we have the trace out of the center. I will now adjust. We have here 0 volt. We have here 0 volt applied. I will now adjust the trimmer in order to get the trace in the center. We can find here that this trimmer has a appliance in the horizontal position. Now we have the trace in the center. We can move the line up and down, as we must adjust this trace rotate. Here we have rotation of the trace. We can adjust this by this screw here. We can unscrew in order to compensate if magnetic field failed. I hope that we have now high tension here, high voltage. I will rotate here we can rotate. As you can see, we can rotate the whole CRT TV in order to get a parallel. The line must be parallel to this gear here. Now it's okay. I will now tighten the screw maybe it must be in the horizontal position. We have to get the best correction. Here we have the best correction. We now apply the cal 2 volt here. We have 2 volt voltage here. Yeah, we got a sine wave here. I haven't the manual, user manual. I will apply some voltage and we will see. Now I will test this scope with the function generator. It's a Tabor model. I will power the scope. In order to use this scope, you need the BNC to banana adapter. I have only those leads here connected to this coaxial cable. I will now power the generator. We have 1 kHz signal with 5 volt. I will now output a sinusoidal wave. Here we got the wave. Now we can switch to another form. We have a triangular wave and we have square wave. They said it has 5 MHz bandwidth here. I can modify the frequency. Now we can output 10 kHz. We can adjust the time base. All the knobs works fine. We have here the focus, here the amplitude, here we have the horizontal position, here we have the vertical position. I can now try to input a large high frequency wave. We can, if we have 1 MHz wave, I can try to vary this. Now we can see here for the maximum we have 1 MHz wave. Now we can choose the 5 MHz as the maximum frequency. We can adjust the sweep var gain here. Can adjust. I can here 100 Hz. Here we can see the wave, barely the wave. We have here 5 MHz. Of course, if I get the dock, I will do a calibration for this scope. Now we will lower down the frequency to 5 kHz. This is for the amplitude, of course. We have some noise here. Now we get to the end of this video. Thanks for watching, and have a nice time.